So this section is on the enhanced driver, which, last session we were talking about the advanced drivers and all the backups they can do and stuff like that for Cisco's and some of your more common network equipment like that. The enhanced driver we came up with to let us manage and configure devices that we don't have a driver for. So it's a flexible one that we can basically teach how to log in and out of a device on the command line. And then it's got the ability to use the rules engine to run commands on those devices and then look for responses. And so that lets us build out, automation like monitoring and, things like that. And then also we have the ability in the enhanced driver to do backups on a schedule or on demand. So it's kind of it's more than the dumb native driver, but it's not quite as much as the advanced drivers are. It's kind of in the middle, and it lets us configure a device. In this case, we're looking at a firewall. A lot of the stuff that we use this for are firewalls or riverbeds, WAN accelerators, that type of stuff, where you have some of them around, but they're not your bread and butter systems. So when you want to configure one of the ports with the enhanced driver, you just run config init, just like we did with the Cisco's last time. But this time, instead of Cisco for make, you give it enhanced, and that opens up a couple more options for us. You'd give it the management IP as usual, but then instead of just asking for username and password, we need to define for the enhanced driver what the command prompt looks like so that it can recognize it when it gets logged in. So if you look at the defaults there, it's the kind of the 6th or 7th line down, it says command prompt, and you notice we've got the # and the greater than, because those are the two most common prompts that you see when you're on a command line, right? If you're working with the Cisco or something, it's either got a caret, that greater than symbol, or if you're enabled, it's got that # symbol. So that's what our software looks for to know that it's logged in properly, and for executing those automation commands and stuff. Then the next thing you need to do is tell it what the login prompt looks like. And that's just what we've got in there, the default. That's a bunch of regex that recognizes pretty much any login prompt. But you can simplify it. In this example, we just cut that down to just login with some white space behind it. And then same, you tell it what the password prompt is going to look like, how to log out, and also how to wake up the console. Because most consoles you have to hit enter before it'll show you anything, and so that's what that command is for there. And then just like the enhanced or the advanced drivers, you give it a username and password to log in with, and then you can configure the serial bit rates if you need to. So that's how you set up the enhanced drivers, and it's pretty straightforward. The trickiest part is getting it to recognize the login prompt sometimes, but this big regex that we've got there works pretty well for that actually these days. And so then just to dig into this a little bit more, that's just for each of those options, you can define what it looks like. If the defaults we have in there, like if you have a system where the command prompt isn't a pound or a greater than sign, you just need to enter something that system uses for its prompt so that we can recognize it when we're actually logged in. This is kind of this section is designed to sort of help you with regular expressions if you haven't used them too much. The regular expressions let us match text basically. And so, when we're trying to find the certain things, you have options with regex, right? The brackets lets you specify multiple things to match, right? The pipe separates alternative options. The parentheses lets you kind of group them together and give it a preference of recognizing things. And then, the asterisk is a kind of a wild card character like you're used to, where it'll match, you know, 0 or more instances of a certain character. So, and then yeah, there's some additional. The /s represents white space, so that could be a tab or a space or a new line or whatever. So regex, this is all just to help you build out some regex that's going to recognize the prompt on the system. And when it comes to it, if you guys end up using the enhanced driver, we'll probably help you, configure all this and build all this out. So, I wouldn't worry too much about, um, trying to figure out regex if you haven't played with it before. So, just some examples. If the command prompt, right, it looks like host name with just a greater than, you can edit that down to just that. And similarly, if a system, uses password for a password prompt instead of in the below, it's user secret, for example, or username, it might look different. So, you just have to configure the driver for that port with whatever is going to match on the system itself. Now, when we're running commands on the system, the default timeout for us to wait for a response is 5 seconds. But some devices are kind of slow when when you run a command and it takes it a while to give you the output you're looking for. So there's a property you can adjust for that. If you do config properties, we have this enhanced timeout seconds, and then you give it an argumented seconds. So if we're working with a system that we run a show status command and it takes 15 seconds to come back with all the info we want, you can adjust that timeout. Now, like I said, the enhanced driver can be used to do backups. Basically, what we do is we figure out what command you use on the system to transfer those files, and then we put that in quotes in a pull tft command. So, here you've got pull tftp, which we also support scp for that, but and then you give it the command to run on the system. In this case, it's going to upload a configuration to the local manager, right? That's the local manager's IP address there. And then, what's the file name and where do we want to put it? That's the current running config in this case, but if we were backing up the OS instead, we would put it in the OS current instead of running config current. And you can do the backups on demand, just like this. The top example is running it once right away, but you can also schedule those. And that D86400, that's in seconds, and I believe that's a daily backup. And so that works the same. You do config schedule, you give it an interval that you want it to do it on. That's going to be how long it waits before it runs the command again. And then you, just like above, you give it the command to run on the system and tell it where to put the file. And then when you run that schedule, of course, it's going to ask you if you want to confirm the job, and it's going to test it at that time so that you can make sure it looks good and that it's going to work for you. So that's backing up, and that works for either configurations or OS images. Basically, any file you want to back up off those systems, you just tell the Uplogix what command to run, and it'll just run that on a schedule. You can similarly push files back to the systems, right? Not only can we pull them and back them up, but you can either manually or on a schedule push those files to a system, and it works the same way. You give it the command that you want it to run on in this case on the extreme switch, and then where you want to put the file, or which file to use rather to transfer down there. So in this example, we've got a golden running config that we will have backed up on the Uplogix, and so you can push that down on demand or on a schedule if you want as well. Yeah, SFTP works the same basically, but because SCP supports more user authentication, you need to work with that a little bit. Now for that, we've automated some of it a little bit. In this example, you see there it says pull SFTP, and then the command we're running on the system is SCP, but then we give it this $user, $IP, $path stuff, And what that lets us do is that lets the Uplogix just put in the proper user for the Uplogix, the proper IP for the Uplogix, and the proper um, location for it to save the file. And that lets us just do that automatically, so that you don't have to enter that stuff manually. Just to compare, if you look in the previous one, the TFTP, we have to tell it, hey, this is the IP where the Uplogix is. With the SFTP, with the secure copy, that's automated. The Uplogix will automatically fill in the IP, the path, and the user for that. And then that also can be done on demand, the SCP, or on the schedule. So in this example, we've got it on that same daily backup schedule at 86,000 seconds. And of course, those can be scheduled as well, both push and pull with SCP and with TFTP. So that's how we do backups. It's a little bit more manual than with the Cisco driver, for example, but it can really, work on any system. Just you have to figure out what command to run on that system, and then the rest is just a matter of IPs and so forth. So like we were saying, with the rules engine, you can add a lot of functionality. You can build out automation, monitoring, automated recovery, that sort of stuff. And we'll just use the rules engine for that. Now, for the most part, in the rules engine, you're going to be using the action execute rule action, and that's just where we give it a command to run on the device, and then we can also collect responses. So the output from that command that we run, if it's got CPU usage percentage, we could collect that and put it into a variable in our rules engine. So we collect it, we run a command, we can collect a response, and we can store that response in a variable that we can then compare to other rules and build out further complex automation based on that. For example, if we run a command where we're checking on the status of the device and we get an error message that's like critical alert, we could have another rule that then sends you guys an email when we detect that status, or maybe it creates an alarm that is going to bubble up through the control center into your SNMP tools and so forth. So we'll have some examples here. So this was something we built out for Hughes satellite modem, where the rule sends a C, the letter C and the letter A, to the satellite controller, and each of those is a command on the Hughes that outputs RX code and TX code with the number. And so we collect that number, and this is what that rule looks like. The condition is true because we just want to run this all the time. This isn't something we only want to run sometimes. We're just going to always be pressing C and pressing A and looking for RX code and a number, or TX code and a number, and then collect that. So once we've collected that number from RX and TX, then we have two more rules that look for particular responses, right? RX code 5 means that the receiver is not locked on the satellite modem, so that's like link loss, on a router, or cable unplugged. So that's a problem. So they asked, we had some customers who asked us to help them automatically detect that. So if that A command comes back with RX code 5, then we create an alarm that says, hey, this satellite receiver isn't locked to its satellite. Similarly, we have another rule that when TX code comes back 8, that means that we've got a transmit error on that satellite modem, and so we create an alarm based on that. So this is just one example of 3 simple rules that just run a couple commands on the system, collect the response, and then look for a couple of particular responses in there. Yeah, and then when you want to go ahead and schedule that, it's you just use config monitor on that port, and then it's a chassis monitor that uses these 3 rules. The pipe indicates that it should run them all in sequence. And we'll go into more detail on how the rules engine works in a later section. But this is just to show you, the kind of basic, simple automation that we can build out to, just monitor a system and let you know when we detect certain problems on it. So yeah, getting into the labs, we can, I want to go ahead in the WWT lab, we're going to go ahead and clear, and actually you don't have to clear the port if you don't want to, but I want to run config init and initialize the Cisco ports we're using as an enhanced port instead, just to kind of show you how that works. So here's that lab. If I click through back into the lab, so yeah, like I said, I want to go ahead and we're going to go ahead and use the enhanced driver instead of the Cisco driver on one of these devices. Yeah, oh, I might as well log back in. All right, there we go. So, yeah, and it's probably a good idea to do 2 SSH sessions again, just so you can kind of see what's happening in the background. So that's what I'm going to do again. Let's go ahead and log in here. And I was working on port 29 previously, and so I'm going to start a second session. All right. So going back to that same port 29, and if I show info on that port, it's going to show us what the current is, right? It's running Cisco, and has this IP and so forth. And like I said, you can use config system clear port to remove all of the configuration from a port, but I think just config init might be better here. So let's tell it, yes, let's reinitialize, right? And description, this will be, user defined, because the enhanced driver isn't going to automatically pick that sort of stuff up. But I tell it we're going to use the enhanced driver instead of Cisco. Model doesn't matter in this case for iOS anymore, or the OS version. But the management IP we do want to retain, so that's good to have for file transfers, and also we can ping it. The command prompt I would leave as the pound and the greater than, because that's going to match either of the 2 existing Cisco command prompts. And I would leave this last login prompt as well. It'll recognize login or username, and on these Ciscos, of course, they don't actually have a console password set, so we don't really need that part anyway. Or the password. Exit will log it out. That's good for that, and enter should wake it up. So the defaults we actually kind of designed to work with Cisco, so we don't actually need to change any of this. But yeah, the device doesn't have a console username and password, so we can leave that blank. And the enhanced driver doesn't support like enable at this time, so we don't have to worry about any of that. So once you've entered that info on your other SSH session, I'm going to do a terminal shadow here, so just so we can watch what happens. And currently it's not doing anything because well, that Cisco driver might still be trying to do some stuff. But when I commit the changes, it's going to test the login, right? Which for it means it's going to hit enter, make sure it could see the command prompt, which it looked like it did that fine. But it's funny, I expected it to see it do something on the right-hand side there. If I do show buffer, we can look at what's happening there. Yeah, so basically it just hit enter, and it saw the prompt, A Thompson and the greater than symbol, and so that was enough for it to test that successfully. So at this point, if I need to work on the device, I can terminal in. It works just the same, right? It gives me the command prompt. I can enable manually still, of course, using that same password, do what I need to do. And this is really just more of an example than practical use case. You wouldn't want to use the enhanced driver on a Cisco because it does so much less than the Cisco driver. But it's just a good demonstration of kind of what we can do. Another good example, just while we're playing around with it, let me show you on our support site. We have um, written some configuration guides for a number of different things that use our enhanced driver. So, for example, the Palo Alto, we actually have a version, this is version 7, works with the latest version 10 Palo Altos. You know, there are, if you look on the left-hand menu, we have a number of different devices like, you know, Palo Alto, Checkpoint, you know, some satellite equipment that we've developed configuration guides that explain how to set these up with the enhanced driver. So, for example, with the Palo Altos, same thing. You run config init and tell it to use the enhanced driver. You know, give it an IP and a username, and then you know it's going to check to make sure that the login works. And then here's how, you know, some pre-written examples of how to back up your config off the Palo Alto, right? Using either TFTP or SFTP. So, you know, with an example of actually running it there. Same with that scheduled backup, right? If we want to back up that config on a schedule, you know, we just use this config schedule, and this example, you know, should work on in Palo Alto. You know, we've got a section on restoring your configuration as well. And then here's a rule set that we built out that's just a simple, you know, CPU, memory, and heat check. So, you know, and this is it's about 6 rules. Each rule, or you know, they're kind of in pairs. So, you know, the CPU check rule 0 and check CPU check 1. These work in tandem. The first rule, you know, it runs this command: set CLI scripting mode / show system resources. A little bit of a tongue twister there. And then we're going to collect 3 digits in a percentage format, right? It's number, dot number, percent idle is what we're looking at there when we run that show system resources. And so we collect that percentage, and then the next rule evaluates that, right? If the way that I've got it written right here, it's triggered if CPU idle is 99 or above, right? That's going to trigger it all the time, basically. But you could just adjust that, you know, to if CPU idle is 20%, throw an alarm. That means you're at 80% utilization. Or it could be CPU idle 5%, right? Or 1%, whatever you want to set that threshold to. Same with the memory. We have 2 rules. One that runs a command that collects the amount of kilobytes that you have free space on the disk, and then or rather that's running memory, and then a rule that, you know, alarms when it's below a certain level. Same with disk space, right? We've got a rule that runs a command that checks on disk space, and then because that Palo Alto has a number of disks, it has 5 disks that we might be that we're monitoring individually. It has 5 different comparisons that it does. So anytime it's over 80%, we'll throw an alarm based on that. And of course, you can adjust that just by changing these numbers when you configure it on the Uplogix. So that's oh, and then of course for the Palo Alto, we do port forwarding to the web interface, which I can show you that feature. That's in we'll talk about that in the enhanced or the it's one of the last sections of the training, actually. So yeah, so you know, we have a number of these configuration guides that kind of walk you through how to use the enhanced driver on certain systems. And if you guys end up with you know, some type of device that you need to monitor and manage, you know, similarly, you know, we'd be happy to work with you guys to develop all this sort of stuff. It's not that it's particularly complicated, but you know, we've just done it a lot, so you know, we know how to make it easy, and we want to do that for you guys. That's the end of this section. Actually, it's a little bit shorter section than some of them, just because it's focused on the enhanced driver. It's great for picking up, like I said, those those odd devices that you end up with here and there that we don't have a advanced driver for already.